What on earth is an algorithm? Where does every good piece of research start? A search engine. So what is an algorithm? Can I even spell it? Oh, I think so. Okay. A process or set of rules to be followed in calculations or other problem-solving operations, especially by a computer. Sounds like a riddle.
After an hour of searching about the internet, it all felt a little overwhelming. So many different definitions without any clarity in what they actually do. During my search, I came across Professor Victoria Nash from the Oxford Internet Institute. I called to pick her brains.
We would tend to explain an algorithm most simply as a set of instructions. So
Right.
an example of a non-internet based algorithm would be something like a recipe, for example, that gives you a set of instructions as to how to put together several ingredients and get a product, say a cake, at the other end. And online, an algorithm is effectively the same thing. It's a set of instructions that enable a computer, a program, to put together different sources of information and generate a result.
Speaking to Victoria has helped me understand what algorithms are. But how can the same thing that helps me bake a cake also give me the best results from a search engine?
No idea.
I'm taking a trip to Oxford to visit one of Victoria's colleagues, Dr. Bernie Hogan.
Bernie,
Hi.
great to see you.
John, nice to see you.
Where on earth are we?
So this is our university's data center. It's, it's pretty big. It's really noisy.
Really noisy.
There's a lot of computation happening here. Each one of these belong to different departments. They're doing different kinds of calculations.
So there's thousands of algorithms going on in all of these massive boxes like now.
Thousands. Try billions.
Billions.
Billions of algorithms.
Shall we go somewhere a little bit quieter and talk in a little bit more detail and try and get a better understanding of how all of this works?
Sure.
Let's do it.
Let's do it.
It's weird to think how much of our lives go on in nondescript server rooms all over the world. But what exactly are these billions of algorithms doing?
So the reason that we use a list of instructions is because we have a lot of data and we have to deal with that data. Now, data could be anything. Data could be a list of towns in the UK and how I get from one town to another. It could be a number of tweets. Which tweet is going to show up at the top of the list?
Right.
Algorithms calculate, based on a bunch of features, the sort of things that will put something at the top of the list and then something at the bottom of the list.
So if it's that simple, should we be scared of algorithms?
Well, the trick with algorithms that we perhaps should be a bit concerned about is what happens in the black box.
So is that like when you search for something, you don't know what their algorithm's doing because we can't see it?
Well, a classic case of this is people talk about searching for prices for flights. And depending on which day you search on, you might get a different flight, where you search from, and so this can mean difference of hundreds of pounds. That's an example where an algorithm is not transparent and perhaps should be.
Can algorithms think for themselves?
Well, we wouldn't necessarily think of a computer as thinking, but we know that algorithms can learn. And they can learn from other algorithms, and algorithms can create their own instructions now. But the basis of it is still the same. Data goes in, goes through instructions, result comes out.
I'm beginning to get it, but I've still never actually seen an algorithm. I don't even know what they look like. So I'm heading to one of the UK's leading coding schools to see for myself what goes into making one.
So this is code, right?
Yeah.
So what's the difference between an algorithm and code?
Coding is algorithms that a computer can run the instructions for you. So we have to do it in a language which the computer can actually understand. So we've written this in Scratch, and it's really nice to use, really intuitive, and you can just drag and drop these blocks, and we've got these instructions for the drone to follow.
It's going to do a flip.
It's going to do a flip. I hope it's going to do a flip.
It's time for a challenge. A drone race. Izzy's algorithm versus me.
So the course is through the hoop, do a flip, come back round, land, and again.
So technically, because yours is programmed by an algorithm, you should be able to do exactly the same thing 3 times without a problem.
That's the plan. You
Right,
ready?
okay. Challenge accepted.
3,
I don't know what
2,
I'm doing.
1.
Ah! Take off.
Okay.
Yes. Right.
So we're going to set the speed, fly up, and then it's going to fly left. You're already ahead, but I think mine's more reliable. Hopefully
This is
it's
really
going to go
hard.
forwards. Go forwards. There we go.
No!
Nice.
How did you do that?
A
Yes.
little turn.
I'm going to make the time back in speed. Speed.
Oh.
Ah!
And then
No.
forwards.
Go, 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 go. Yes.
Oh, whoa, whoa.
Oh. Sorry, cameraman.
I mean, I can just go and make a cup of tea. I'm just going to leave it.
No.
And down. Oh, look how calm.
Have you done your 3 laps?
I did do the 3 laps, yeah.
So you've won?
Yes. So I think some of the big benefits of having algorithms versus kind of humans is that you don't have the human error that, no offense, I think you had.
What are you talking about?
Yeah, you don't have the human
sabotage.
error in the same way. The computer goes through the instructions and that's all they know how to do. The person writing the code could have written an error, and that's where problems can arise. But it's actually, the computer doesn't make mistakes. It just does what it's supposed to do.
A computer might only do what it's supposed to do. But what are the ethical considerations around algorithms making so many decisions for us?
One of the public concerns is that computers are taking over the world, robots are going to take over the world, algorithms are going to take all of our jobs. Is that going to be the case?
Taking our jobs, it's possible, but also de-skilling humans. If we become too dependent upon them and too trusting of them, it can de-skill us as well. But on the flip side of it, they can be hugely beneficial and useful, speeding up decision making, making the whole processes efficient, maybe spotting things that we might not have spotted ourselves. So we mustn't be frightened of them, we just must use them in the correct manner.
What have we learnt then? Algorithms are actually remarkably simple. Just like Bernie said, data goes in, follows a list of instructions, and a result comes out. In some parts of the world, algorithms are now used in the criminal justice system, in social care, in credit checks. They're prolific. Machines making decisions that directly affect our human lives, not just the adverts that you see on the internet or the people you match on dating apps. The question for society isn't the algorithm, it's who controls the algorithm and where the data comes from that goes into them.
Algorithm is step-by-step list of instructions. So to bake a cake, we can express it as step-by-step typed up instruction or as a flow chart. Mix ingredients, pour into pan, put it into the oven, bake until ready. If ready, remove, let cool, serve and eat. The great thing about a flow chart is that it can actually show some decision elements. For example, we don't know if it's ready. We test with a fork, and if you've baked before, if the fork is too moist, you pop it back in. So it's good enough. But then an algorithm gets refined. So algorithm refinement, you start to put the category of the step and then the refined steps underneath that. So mix ingredients actually includes mix up wet ingredients, and 1.2 is add wet ingredients to the dry. That in turn could have its own refinement, but I think you get the idea. Even baking, you've got the minutes described here, but you've got check if risen. So that in itself is a refinement. Then you've got remove. What does that mean? Then you've got serve and eat, which is actually 2 separate points and could be refined further. And that's essentially what you need to know about algorithms. Where it becomes interesting, far more interesting, is where the algorithm gets turned into pseudocode. So what is pseudocode? Well, as soon as that should be, work out the steps with no ambiguity, that should be then we can say it has been written in pseudocode. So as soon as we've got steps that have no ambiguity, then we can say it is pseudocode. But pseudocode has a certain format or a set of rules. So how do we structure pseudocode? Well, that's the rule. We look at our inputs, we look at how we process those inputs, and then we see what sort of output or print out we need. Okay, and that's the basic rule. If you remember that, you'll understand how to structure something like our first problem. Simple problem number 1. Determine the sum, average, and product of 3 numbers. We can solve this by writing out the steps or a flow chart, and then we can convert these steps to code using VB.NET. But first of all, pseudocode. So start, read, is that input, process, or output? S, which is our sum, equals x plus y plus z, and so on. And write, is that input, process, or output? And then stop. The start and the stop are essential in a flowchart, not always essential when we simply write it out as our pseudocode. So this is pseudocode. Read, that's definitely input, X, Y, and Z. Compute, well, compute is the same as process. The sum, there's the average, and there's the product. And write, well, that's our output. So going back to that, that's input, process, output, and we can see those steps clearly in our flowchart and our pseudocode. Let's put that simple problem into structured pseudocode as per what the exam board expects. And there it is there. So determine the sum, average, and product. I've set off two numbers just to make it simpler. So this is how we do our pseudocode. We look at our input, we look at our process, and we look at our output. If you can remember that, you can structure anything into pseudocode. So what is our input? Well, our inputs are two numbers. What is our process? Well, we need to know what to do with those two numbers. So with sum, average, and product, there's a process, and we need to work that out. This is actually a process within a process, if you like, but they're still using the same assigned inputs, the same numbers, and this is our output. We're going to print out the result of the process. Carrying on with simple problem number 1, I've actually put this now into pseudocode. So